Okay, so I need the link. I need a wiki page. Guests. Here we go. YouTube link. And let's turn on the screen sharing. There we are. Oh, not quite yet. Not quite. There we are. All right. Welcome to. Oh, is my mic? What's wrong with my mic? Here is my mic fine.
Your mic is fine, yeah.
Okay, because I just got the Jitsi notification that something was wrong with my mic, but probably a false alert then.
We've heard the same sentence twice, but other than that, it is fine, yeah.
All right. So, welcome to Thursday's edition of X2Go the Spread 2023. And today we'll take a look at how you can boot X2Go-TCE-Live with iPXE in EFI and Legacy BIOS mode. So, first of all, why use X2Go-TCE-Live and not X2Go-TCE-NFS? Well, just like the NFS version, it needs a PXE environment, a TFTP server, and an X2Go server. And in addition to that, it needs a web server, but it does not need an NFS server. And once booted, it runs directly from RAM. So the only component that needs to have redundancy or high availability is the X2Go server. You do not need an NFS server that is highly available. So any other components may fail during your workday without affecting the clients that are already booted up. Next, what is iPXE? iPXE extends the PXE environment with some really cool additional features. It can be compiled from source, but there are also pre-compiled binaries available from boot.ipxe.org. The legacy flavor is called iPXE.pxe, and it needs some additional configuration on your DHCP server side to load the default configuration file, which is called autoexec.ipxe, located in the root directory of the TFTP server. The EFI flavor is called iPXE.EFI, and it will load the default configuration file automatically. So no additional configuration is needed for that. Do make sure you get the latest version from boot.ipxe.org, because older versions do not support loading a default config automatically. iPXE also speeds up net booting considerably by using HTTP or HTTPS instead of TFTP. You can even net boot your clients over the internet, though you should absolutely use HTTPS when you do that. When iPXE is used in EFI mode, there are a few limitations. This is because iPXE does not offer a signed executable. So you either need to disable secure boot or sign the iPXE binary with your own key and install your own key on all of your clients. Instructions on how to do that can be found in the Debian wiki linked here. And if you don't want to go that route, you will have to use Grub instead of iPXE. It offers both a signed executable and a signed first stage bootloader, colloquially known as shim, unlike iPXE, which does not. Now, what iPXE does is that it basically replaces PXE-Linux.0 in legacy mode. However, as it repeats the PXE boot process, care must be taken to not end up in a boot loop. Details on that, plus sample configuration snippets for both ISC, DHCPD, and DNS mask can be found via these two URLs. However, you don't have to mess with config files if you use a modern router distribution with a web GUI. For purposes of this demo, we will be using OpenSense. The TFTP server and the web server can be installed on completely separate machines, on one machine, or even on the router itself. So I strongly recommend against the latter. If you don't want to heed my warnings, these are the plugin packages you will need for OpenSense: OS TFTP and Nginx. Now, in the OpenSense web GUI, go to Services, DHCP v4, and Local Area Network. Be sure not to click on TFTP server. Rather, you need to click on Network Booting. There, set your TFTP server's IP as the next server IP. Then add the default BIOS file name with a leading slash and the default x64 EFI file name, again with a leading slash. And like I already mentioned earlier, the BIOS version of iPXE won't load the autoexec.iPXE by default, so we need to add that as well, again with a leading slash. Now, this autoexec.iPXE file is an ordinary text file, not a binary. All it needs is a proper shebang line in its first line. And except for the first line, everything that starts with a hash sign is a comment, just like you know it from shell scripts. And from previous experience where iPXE would load the autoexec.iPXE file, but forget that it had any IP configuration, I recommend placing this little code block at the very beginning of your scripts. It tries to fetch an IP address via DHCP and won't quit until it succeeds. Now, if you're in a Hunt for Red October situation where you must send one DHCP request and one DHCP request only, then you could also try checking if the corresponding variables for IP, netmask, gateway, DNS, and so on are set, and only send another DHCP request if not. But turning that into code is something I will leave as an exercise to the viewer. Now, I just mentioned variables, and yes, there are some that are pretty much always there because iPXE will set them immediately after it starts up, like the MAC address. Others will only be present if a DHCP request succeeded, and so on. But you can also define and set your own using the set command. Here you can see how the timeout variables for an interactive menu and its submenus are set, with the submenu's timeout variable being assigned the same value as the main menu's one. And this is what a very simple interactive menu would look like. At the top, we set a default entry that will be selected if no choice is being made by the user. Then there's a shortcut key, a long name, and a description, similar to the menus you might know from Pixie Linux. And at the bottom is a goto command, which jumps to a label that needs to match the long name from above. Here we see the goto command again, followed by two of the labels we just saw as long names in the menu, and each entry will chain load another iPXE file. Should it fail, the goto start will send it back to the top and run the menu block again. And here are the remaining labels you saw in our sample menu. We can drop to an iPXE shell and dump some info before doing so. We can trigger a reboot, or we can exit the entire iPXE environment and continue trying to boot whatever is next in the chain, maybe a local hard disk or some removable media. Now, take a close look at the variables here. Platform will be PC BIOS for Legacy Mode and EFI for EFI mode. Also, file name will show you if you're really loading /autoexec.iPXE or something else. File name will include the full path. We can also show the additional menu, the additional information inside the menu, like so. And the neat thing is that it's possible to sort of emulate the behavior you know from PXE Linux, where you can offer alternative boot configurations depending on the MAC address. The only thing that doesn't work this way is partial matching. So you can only match a complete MAC address. But iPXE is actually even more flexible. It can also load different configurations based on the client hostname or IP address. And if that's not enough, since we're loading the file via HTTP, you can also use a PHP script or similar to generate a dynamic configuration. So either by passing variables in the URL and passing them in the script, or by looking at the client IP under which the request was made. Now, what does an actual default iPXE file look like? It's obviously just another iPXE file like the autoexec.iPXE. So it starts with the same shebang line. And here we are loading a Linux kernel via HTTP. And the boot parameters are appended to the kernel line. There's also the line that tells our system where to find the squashfs file for the live image in the same block. And at the bottom, you can see the line required for loading the initial RAM disk. Everything within one colored block goes on one line, by the way. And this is a different iPXE file, one that might get loaded due to a MAC or IP address match. The commands in red force a particular Xorg driver and a particular screen resolution. So after all this theory, let's look at two quick demo videos where you can see iPXE boot in a virtual machine environment. And for that, I need to stop my screen sharing momentarily. So first, I'll show you the legacy mode. So as this is a virtual machine, we're starting with iPXE directly because this machine does not have a classic PXE loader. It has iPXE built in. And you can see autoexec iPXE getting loaded. Here's our menu screen. You can see the information on top with PC BIOS, and it loads our files and starts to boot. And now for the EFI mode, let me just switch the YouTube link. And what you'll notice here is that the EFI mode starts in a different video mode. So the entire screen is already way larger. And we will see that especially as the menu pops up, there's a lot more blue surrounding our menu. Here again, we are loading autoexec iPXE. There's our DHCP request. There's our menu with way more blue to the sides. And we're loading our config files and off we go. All right, that was it. That was a quick overview of how you can use iPXE to netboot a Linux image via legacy BIOS mode and EFI, and how you can set up a menu there, or how you can boot different configurations depending on MAC address, IP address, host name, or whatever. Any questions? Doesn't look
So
like.
hi, by the way.
Hi, Mike.
Hi.
So if there aren't any questions, I guess we can stop the stream.